Hi, so I want to do a conclusion on my Arduino Uno projects that I've did, and probably the four big ones anyways, which is going to be my fuel injection. This is the one that you guys, most people view and ask questions on. Then I have my mile per hour gauge, my uh, torque or my transmission for my overdrive and fourth gear, or my fourth gear overdrive, and then my torque converter lockup. Fourth gear is overdrive in that one. And then also my Corvette 5 gauge cluster I made. All these are Arduino projects, or at least Arduino based. And I want to kind of go through the cons on the fuel injection one first. So a couple of things is what I wanted to do with the fuel injection is I wanted to put this on a sand rail to break in the motor. And then after I broke the motor in, I was going to buy a carburetor for that sub unit. And that was for my personal thing. But I also at the time was rebuilding other motors, and I didn't want to buy a bunch of different carburetors for these units or these motors and then have the carburetors sitting on a bench when I got rid of the motor or sold the motor, etc. And I didn't want to have to buy a bunch of different carburetors. When you break in a motor, you really need to match the motor with the correct CFM, with the horsepower that motor is going to get. And with that being said, I just didn't want to have to buy a bunch of carburetors. I was trying to come up with a way to save some money. Long story short, I ended up having to buy all the carburetors anyway, and the Arduino Uno just did not perform the way it should. And I tried a couple other things prior to the carburetors as well, and I will go through that because this is, like I said, probably the number one thing that everybody asks about is my fuel injection. So after I got about 5 sensors hooked up to that thing like really lagged, and it did not do well. It did not perform well. And I tried bench testing it. I tried just different types of fuel injectors and stuff like that, because I figured once I built the fill map and everything else like that, I could, restrict the CFM per unit. But it just didn't work out that way. The TPS, the throttle position sensor, the mass airflow sensor, and the coolant temperature sensor were the three that really got me close. And then I tried to put a vacuum sensor on there, and that started to lag things out. And then the O2 sensor really lagged things out. But it did do better with the vacuum sensor. But at the end of the day, these were never intended to be like roadworthy or anything like that projects. This was just something I wanted to try in the wintertime, and it was really good educational thing, and taught me a lot of stuff about the Arduino Uno. It also taught me a lesson on what they can and cannot handle. And a fuel injection system, in my opinion, it cannot handle it. They sell an FI Tech unit, and I'm going to say FI Tech unit because this is the only one that I have experience with. I know that they have a Holly Terminator, and they got Elderbrock units out there that might be better than the FI Tech unit. I don't know. I can't speak for that because I haven't used them. But the FI Tech unit I have used, and that thing is garbage. And this is a $1,000 to $2,000 unit. And I will say a pro to the FI Tech unit, where it's not as bad as I'm going to make it sound, but for reliability, it is completely trash. The one pro is after you replace all the cheap sensors that they give you with AC Delco sensors, you have a solid unit. To an extent, the only solid that I have on that unit is if I were going to put it in a classic car that I was only going to drive to a car show, let the car completely cool down, start it back up, and drive it home. That unit, I think, will work for that. But if I'm going to drive it to work all day, start it up, drive it to Walmart, start it up, drive it to the gas station, start it up, and drive it home, by the second time I've started that car up, and I've let that because my motor's warm and everything's warm, and then that chip builds up heat, that unit fails. Every time. If I'm sitting in stop-go traffic, that unit fails. Every time. The moment that chip inside that throttle body gets hot, it changes the bitmap, at least in the 2 applications that I had. It changes the fuel mapping and everything else like that. It either runs really rich, really lean, RPM, stumble. It just is a very bad design to have that unit, that the chips, the brains that control everything on top of the motor, the hottest part of the car. It just, big heatsink issue. I've tried, spacers and stuff like that. It did help out in the BMW, and but it did not help out in the Corvette because I couldn't put them in the Corvette because I didn't have the clearance to be able to shut my hood. So what I'm going on with that is if this FI Tech unit that is $1,000 to $2,000 on the ones that I bought and they're trash, not working out well, the Arduino Uno wasn't going to work out. I did try the FI Tech unit to break in motors, and it didn't work out because, you got to let them warm up. You got to do a bunch of other stuff before you can even start to learn your field code. Talked to them, and they said, yeah, it's going to work for what you want. And no, that's just a salesperson telling me that it was going to work, and it didn't. So with that being said, Arduino Uno for fuel injection, not the way to go. I would put FI Tech here, and I would put Arduino Uno right here. I can't speak for any of the other fuel injection ones, but they're not going to work but at least for me, they didn't work the way I wanted them to. I was never going to get the reliability that I wanted out of them. So with that being said, I'm going to jump into the mile per hour gauge, which is probably my most reliable thing that I had on the Arduino Uno. And it's the most simplest setup I had with a Hall effect sensor going on the wheel. As the magnet spins around the wheel, it hits the sensor, it sends the data. One sensor controls one servo motor, and that unit worked really well. It is working well, except for the fact that when my kid was sitting on my lap, she was hitting the button, and as she hit my horn button, it was like I was hitting the reset button on the Arduino Uno, so it would my thing would reset, come back, and after she did that, I think it was like, I don't know, I was letting her play with it, hitting the horn button when you're goofing off. It did burn up my servo motor, so I had to take the dashboard out and then change the servo and put it back on and put it all back together. So that will probably happen again if I hit the horn a lot of times. And obviously, if I'm driving down the road and I hit the horn button, it's going to reset my Arduino Uno. I tried hooking up to its own standalone battery, to capacitors and stuff like that, and it started to be like, well, I'm putting a lot of stuff underneath the dashboard, and I really was not gaining anything. And I mean, so it's also in a classic truck that I drive maybe 50 miles a year. Not really too worried about it. Honestly, I drive it out of pretty much down the driveway and then back it right back up and park it. I just don't put that many miles onto it. I might drive it to one truck show, and that's about it. And so there we go. That's mile per hour gauge. Is it the best? No, I think Speed Hut probably might have a better gauge for me. They don't have the exact layout. I got a big square. It's not circle or anything like that, so I need a custom gauge, so that's why I built it. And a lot of these things, I find that buying the thing that you need for what you're doing, like whatever the manufacturer had on it, is probably the best way to do it. It's going to be the cheapest way by far, because unless you're doing this to get knowledge out of it, and this is just a project. But I always say that whatever the manufacturer recommends, that's what you should do. I recommend what the manufacturer recommends. I mean, that just is what it is. It's typically they've thought about it. So with that being said, I'm going to jump into the next thing, which is my transmission controller, which really was only to control 2 solenoids, 4th gear, or overdrive, and then torque converter lockup. And that's on a 47RH transmission. Also the same thing inside the same truck. I knew right off the bat when I was doing this that the horn issue, because I just experienced this with my kid playing in the seat and burnt that servo motor up, but I also noticed that it reset the chip. So that was going to reset my unit. And I tried capacitors. I tried a bunch of stuff to get that noise, and to get that to not do it, I had a horn hooked up. I had 12-volt battery, everything laying across the bench. And I'm like, all right, if I can get it to isolate on this bench, I can get it to isolate, or I can get the problem out of not only, my mile per hour gauge, but I also can get it out of here. And I tried and I tried and I tried. I put a lot more time in it than what I should have. And at the end of the day, it didn't work. So I put pressure switches on it. And you got a lot of forums and stuff out there like that. And I'm not going to recommend anything other than say that I would recommend however it was the manufacturer recommends something is how I would recommend something. I can only tell you what I did, because I don't actually have a manufacturer for the way that my truck is set up. First of all, my truck places has been out of business for a very long time. It's a very old classic truck, so there's really no manufacturer to get information out of it. But a lot of people, they hook them up to pressure switches. So that's what I tried. I got a pressure switch. They said 1 PSI for 1 mile per hour. You want your thing to come on at 4th gear to come on at about 40 mile per hour. So I bought a 40 PSI pressure switch. I put it in the truck, and I didn't even test the torque converter at this point. I didn't make a block. I just threaded it right into the pressure port, and I took off down the road. The very first time it shifted, I thought for sure my transmission was shot because it went. So what was happening is, as I was driving down the road, and I hit that 40 psi in the transmission because my RPMs and everything were going up. So as I was driving down the road and I hit that psi and I went above it, it would shift into fourth gear or overdrive, and then it would instantly drop below that pressure, which would unshift it. So I was having that toggle until I pushed on the fuel pedal enough to get over that pressure and stay over that pressure where it shifted and stayed in that gear. Learned real quick that recommendation that they gave, which is why I don't recommend anything anymore, just because of stuff like that. Things can go bad if you recommend. So manufacturer is always the way to go. But the thing that I did is I actually got pressure switches that were different. I got on-off pressure switches. So the pressure switch will come on at a certain PSI, whatever I program it to, and it won't shut off until it hits a different PSI. Both programmable. It doesn't matter the configuration. I can have it come on at 30, stay on until it hits 40, and then go off. So it can be like on, off, on, or I can have it come on and then stay on, and then, as it's in here, it's still on, and then come off once it hits this. And that's how I did it. So pretty much once I hit I think it's set it at like 42 PSI, it'd come on at 42, stay on, and then it wouldn't shut off until it hit 30, 28, something. I can't remember, but it was low PSI. So when it would get above that pressure, it'd stay on, even when they would have that little pressure dip from shifting. And that works out really well. But still, there's better ways to do it. There always is. The manufacturer way is typically always the best way. And if I had another way to do it, I've actually bought transmission controllers, 47 or EZ TCU for my. It'll come to me. 4L80E transmission that it's in my Corvette. So I bought a unit for that just because it's pretty decent. Their customer service isn't the best. It's actually really not good at all, but they do make a good unit. So I can't really say anything else like that. If you've got questions and stuff, the forums are pretty much better than them because their customer service might be better. It was also like 3 years ago. So now my Corvette gauges. Now this is probably the biggest one that I spent a lot of time on, and it worked really well. Anyways, I let my car sit over winter. I didn't hook it up to a toggle charger. My battery ended up dying, and so I went to start it, and I got click. Charge the battery up. I probably didn't charge it up long enough, so when I started it, the either my alternator was already on the verge of going bad, or just that combination of the battery said it was ready to start. I was at like 95% of battery charge, but I started up the car and I drove about a quarter of a mile and I lost my alternator. And once I lost my alternator, it kind of made all my gauges keep on resetting. So they'd come down and reset, come down. And I was like, okay, well, that's just, I lost my alternator. I don't have the charge that I need. I replaced the alternator, replaced the battery. And then what ended up happening is the same issue. Once it developed, it stayed on there. And I'm like, why are my gauges resetting? I mean, I did so much time, custom made a chip, did all this stuff, got the noise, figured it all out. Well, I put a remanufactured alternator on there, and I ended up having to buy freaking multimeter, like a really, really good one that will read AC ripple and all this other stuff. And I found out that the alternator they gave me, which was a remanufactured one, actually was bad. A brand new alternator, remanufactured alternator was bad. So I took that alternator back. I've had this happen once before where I've got a bad alternator, but it was actually charging to the correct voltage, so I didn't know it was bad. The other one just wasn't charging at all, so it was obvious that it was bad. But this one wasn't. It was throwing an AC ripple, a way big AC ripple, which was shutting the Arduino off, and it was making it shut on and off. I ended up having to buy a brand new alternator, put that in there, very little AC ripple. Thing worked out really, really well, but it was after me putting another chip in there and trying to problem shoot and all that other stuff. And at the time, I went with that because I already had Arduino background. I knew I could make it, but I think I had like $600 in this Arduino chip and the prototype and everything that I built, and the gauges would have cost me $500. I mean, just to buy the brand new Corvette gauges, mine were all rusty, and to buy the actual gauges, I would have been out cheaper at the end of the day. So, I mean, it was a good project, it was fun, but I would have been cheaper had I bought them. So I guess the big thing is, I mean, this kind of concludes all this. I do a lot of, machining and stuff like that. I just really wanted to do a conclusion on my Arduino projects, and I'll probably still do a review from here to there, but most of my Arduino stuff is going to be concluded with this video. I just want to let you guys know that. And thank you guys for watching. This should answer pretty much all the questions that you guys have on all this stuff. I know that a lot of people ask for codes and stuff like that, but this stuff is not designed to be in a real world application, and I just feel like if I were to post my codes, you guys would use them and try to use them in a real world application, and I don't think that's the safest thing to do. So with that being said, I'm not going to post the codes. I know that's kind of like, I'm sorry, but I think that safety is the number one thing, and these were designed for certain applications or certain thought process, and I could tell you where each one failed, and because of that, I would not think that any one of these are reliable for any type of application. So that, it just is what it is. So thank you guys for watching. I appreciate all the views and everything on the channel that I had and my videos, and I hope this helps you guys in anything or any questions that you may or may not have had. And I'm going to be doing more machining videos and stuff like that, kind of like on the farm videos, because that's what we're doing here. So anyways, thank you guys for watching. If you got any comments, questions, subscribe, let me know. And thank you guys. I'm going to keep more review here and there coming up and stuff like that.